Welcome to the walkthrough for Assignment 2A. The purpose of the first part of this two-part assignment is to deepen your experience using Java 8 functional programming features and their integration with Java 8 sequential streams. In particular, in this assignment, you'll develop an app that uses Java 8 sequential streams to obtain, transform, and store images. The code you write for this assignment has a GUI and runs as an Android app. Please feel free to use this app to help debug your solution. The following resources may be helpful in completing this assignment. Detailed overviews of Java 8 sequential streams are available in videos 20 to 24 in one of my YouTube playlists. Naturally, we'll cover this material in class, which will then be available in my YouTube CS891 playlist at this highlighted link. There are also good overviews of Java 8 streams at the highlighted links here and here. I highly recommend you get the book Modern Java in Action to learn more about Java 8 streams programming. Before you complete the initial assignment and submission for Assignment 2A, you'll need to do the following. Complete your implementation of Assignment 1B, taking into account my review comments. In particular, it's important that your array implementation works properly, since it's used as the basis for the app in this assignment. Please come to office hours if you have any remaining questions about your Assignment 1 solution. The Image Crawler app is packaged as a project using the latest version of Android Studio. The app's written in both Kotlin and Java and demonstrates many Android capabilities. For the purpose of Assignment 2A, however, you'll only need to be aware of the following three directories. The Image Crawler Utils directory, which contains the skeletons you need to fill in, as we'll describe below. The app source test, which is a set of JUnit tests that exercise the features under test and can be used to evaluate whether you've correctly satisfied this assignment's requirements. And the Android test for Assignment 2A, which is an Android Studio instrumentation test that runs your app automatically. As always, to compile this code, you'll need to use the provided Android Studio project. You can run this project by clicking the green Run App button in the Android Studio IDE, which should automatically select an Android emulator to run, assuming you have one created. The application's minimum API is 26, so you'll need to select an emulator that uses an API greater than or equal to 26. If you haven't already created an emulator, you can create it by clicking on the AVD Manager button in Android Studio IDE. In this first part of the assignment, you'll complete the implementation of an image crawler class in the image crawler crawlers sequential streams crawler.java file that obtains and stores images. This class uses Java 8 sequential streams to perform an image crawl starting from a given root URI. Depending on the parameters used to run the test, images from HTML pages reachable from the root URI are either downloaded from a remote web server or read from the local file system, and the results are stored in files. The bulk of the code for this app is provided in the skeletons. In fact, a complete solution using Java 7 features is provided in the image crawler crawlers sequential loops crawler.java file. You will therefore focus on converting this Java 7 based class to the sequential streams crawler class that uses Java 8 sequential streams. Undergraduate students must do the following. Implement the key methods in the splitterator interface in the image crawler utils unsynchronized array.java class, which was done by graduate students in Assignment 1B. You'll need these methods for Assignment 2B, so now is a good time to complete them. Likewise, graduate students, or students who are taking this course for graduate credit, must do the following additional work. Implement the image crawler utils synchronized array class, which will then be used for the Assignment 2B's array collector class, which is not included in this assignment. Undergrad students should ignore the synchronized array class for now. Your solution should use no loops in this assignment and instead use Java 8 sequential streams aggregate operations. The skeletal code for this assignment is available in my GitHub account in the usual place. Now that you've set up your GitLab account and you know how to use it, you can pull my skeleton code into your repository, read it carefully, and complete the to-do markers. JUnit unit tests are available in the image crawler source test Java folder, and they're provided to increase our confidence that your implementation is working as expected. You'll need to learn how to use the Android Studio GUI to run the JUnit test locally on your computer, as described at this link. As usual, testing only demonstrates the presence of bugs, but not their absence, so don't rely solely on the JUnit test to detect problems in your code. Assignment 2A is more complicated than Assignment 1 and is designed to deepen your experience developing apps using the Java 8 functional programming features and Java 8 sequential streams. In particular, the skeletons and JUnit tests are more extensive, though you don't need to understand them all to complete your solution. Therefore, please make sure you start early and ask questions in class, office hours, and on the discussion forums. Now that I've described the specification for assignment 2A, let's take a look at the skeletons, starting with unsynchronized array in the utils package. You've implemented most of this class in the earlier assignments in assignment 1. So what you'll do, of course, is copy in your revised solutions that include responses and address all the comments that I gave for assignment 1A and 1B. If you take a look towards the bottom of the file, you'll see the new parts that you have to implement that's different from before. In particular, you'll need to implement the array splitterator class. So you'll have to learn about splitterators. We'll be describing them in class, and you'll also get a chance to learn more about those. And what you'll need to do is provide the fields that are described here. You'll need to implement the array splitterator constructor, basically initializing the fields that you define in the earlier part of the class. You'll have to implement the try_advance method, which is going to check to see if there's any remaining elements. And if there are, you will perform the given action, which is passed in as a consumer as the parameter. And if you were able to consume an element, then you'll go ahead and return true. Otherwise, if you're at the end and there's nothing else you can consume, you'll return false. The other method that you have to implement here is called try_split. And this essentially will split the collection in half, what you're iterating over, and you will return a splitterator that covers the elements that will not be covered by this splitterator. So again, we'll be talking about splitterators. You can learn more about splitterators from watching the videos. And the splitterator basically does a divide and conquer, dividing of the input in the array up into chunks, splitting it in half each time. So take a look at the videos and read the descriptions, and we'll talk more about that when we get to that part of the class. Let's now go ahead and take a look at the synchronized array. Synchronized array is something that the grad students or people taking the class for grad credit have to do. Again, you'll have to fill in any necessary fields for this. I'll give you a hint. You'll have to have an instance of an array, and then we're going to synchronize the various methods here to ensure that the access to the underlying unsynchronized array is going to be properly synchronized to avoid race conditions. Most of the methods here are really just wrappers, and they do very little work other than use synchronized statements in order to encapsulate the various portions that could be accessed concurrently. You'll discover, of course, that you don't have to worry about synchronization in constructors because they're only called once and in a single thread. So you can have some simplified code in the synchronized array constructors. But then when we get down to the various methods like isEmpty, size, index of, and so on, you're going to have to put synchronized blocks in all of these places. And if you go back and take a look at some of the early videos we talked about when we talked about concurrency and synchronization, you'll see what a synchronized block is. And it's really quite straightforward, but you just have to figure out how to do the code and then forward to the underlying unsynchronized array once you've properly locked everything. So as you can see, there's a lot of methods in here. One of the ones that's kind of interesting is the to unsynchronized array, and as the specification documentation for the method says, you need to return a copy of the underlying unsynchronized array. So make sure you do a copy of it. And you can use some of the constructors to do that correctly. So that's basically what you'll have to do here. You'll have to implement all those various pieces. And like I said, they're really mostly simple wrappers that just wrap synchronization blocks around the unsynchronized array. So that's a time-honored way of creating synchronization. Not always the best way to do it, but it's a time-honored way to do it. Let's now turn our attention over to the crawlers folder. And you can see here, there's an implementation that I give you out of the box called Sequential Loops Crawler. And this is an implementation that implements all the logic using for loops. And it kind of gives you a hint as to how to structure the sequential processing of the elements, the images, and the pages, and so on. So take a careful look at this code, and you can kind of see what the overall logic is. Now that we've walked through the Sequential Loops Crawler implementation, let's turn our attention to Sequential Streams Crawler. As you can see, this class is an implementation of an image crawler that will use Java 8 sequential streams to obtain, transform, and store images. Let's take a look at the perform crawl method first. I give you the implementation of this method. This method will recursively crawl the given page that's passed as a parameter, and it will return the total number of processed images reachable from that page or on that page. Taking a look at the implementation, you'll see a parameter called depth is passed in, and we compare depth to see whether or not we've reached the depth limit of the crawl. You can set the max depth limit by the app in its setting menu. And if you've exceeded that, then we return 0 because we don't want to crawl indefinitely, especially if there's cycles in our crawl graph. The next thing we do is we check to see whether or not we've already visited this page URI before. And if we have not visited it, we atomically add it to the mUnique URIs map. Or actually it's a hash set, so we don't try to revisit it again unnecessarily. We don't want to end up double counting these links and recursing indefinitely because we have loops and cycles in our call graph. And the last thing we do, we're going to call a helper method called call page, and that will recursively crawl all the images and hyperlinks on this page, returning the total number of processed images. So here is crawl page. The implementation, which you will have to provide using Java 8 sequential streams, will use Java 8 features to download and process images on this page via process image, and recursively crawl other hyperlinks accessible from this page via perform crawl. So it's going to end up calling back recursively to this method up here. And of course, it'll do that whenever it reaches something that's actually not an image, but in fact a hyperlink. And when it's all done, it'll return a sum of all the image counts, either images that were on this page or images that were accessible via hyperlinks on this page. Now, to figure out what you actually have to do here, you go back over to Sequential Loops Crawler, and you take a look at the crawl page method here. And this implementation gives you the code, except it uses Java 7 control constructs like a for loop and if-else statements. But your sequential streams implementation should use many of these same elements. It's just going to use the streams framework and the aggregate operations therein to control the flow rather than using loops and if-else statements. So you'll have to take a look here and kind of see how this is going to work. It's really quite cool. So if you go back over here, you can see that one of the things you need to do in crawl page is call process image. You can kind of see that over here. You can see that if you've got an image, you call process image. If you have a page, you call perform crawl. And that's the same thing you do here. You just have to do it with Java 8 streams. So let's take a look at the process image method that you have to fill in. This is going to process an image at a given URL by applying any transformations that have not already been applied and cached. So let's first go ahead and take a look at how that works for the sequential version using loops. And as you can see here, this will loop through all the transformations in the mTransforms list, and it will attempt to create a new cache item for this transform. But it'll only apply the transform if the new cache item was actually created. In other words, we're not going to do this if we've already cached the solution in an earlier run. So create new cached item takes an image and a transform, and it returns true if you need to actually apply the transform. It returns false if it's already there. So down here you can see we will call apply transform, passing in the transform and the image, and then we increment the image count by 1. And that image count is what's returned as the result of the process image method. So that's how it works with loops and if statements. So your implementation, conversely, has to work without loops and without if statements. So you'll have to use a stream, and you'll convert the transforms list into a stream, and then you'll go ahead and do the other logic that is necessary in order to make this all work properly. So you'll have to kind of figure out how to do this, and you'll also have to figure out how to transform and store each non-cached image. And so you'll use things like map, and you can use other methods like filter and so on. And when you're all done, you'll return the count of transformed images. And that, of course, will be the same result you had earlier, except if you had done it with the loops version, except you will have computed it using streams. So that's basically the logic that you'll have to implement here. And so I recommend you watch the videos, Obviously come to lectures, come to office hours, ask lots of questions. This is not a particularly hard assignment, but if this is your first time learning streams, it takes a while to get your head around how the various pieces all fit together. So now that we've talked about the specification, we've reviewed the skeleton, let's go ahead and take a look at the tests. As you can see, you've got a bunch of tests, and you come down and click on Assignment 2A tests, and you can go ahead and run the required tests. As you can see, it's going ahead and running a lot of tests. It'll rerun all the tests that it had for Assignment 1, 1A, and 1B, and make sure that those things are still working, because obviously if you have some bugs remaining there, then you're going to have problems with this next assignment. And then the other thing it'll do is it also goes ahead and runs tests for Sequential Streams Crawler for both undergrads and graduates. Lots of things it's testing, as you can see. And my implementation, of course, works quite nicely, and that's a good thing. But make sure that you run the tests. It's very important to run the tests. Do not submit your solution without running the tests. If your tests are failing, then make sure you come to office hours, post questions on Piazza, and get those questions addressed, because it's very important that everything work properly. Of course, you can also run the other tests that will have your program start up and rotate. Just a good habit to get into to see how it's working. For this particular implementation, I'm not going to show those things. They work just like they did before, but it's a good habit to also run your program and see how it works. And when it runs with the sequential processing, you'll notice that it does each of the steps one at a time. And so it takes a while to process. When we do the parallel processing in Assignment 2B, you'll see how it all works much, much faster, especially if you have a multi-core processor.